All right, so we're going to review some of the factoring that we did not too long ago. So the whole idea is we're trying to figure out the right combination. So it really goes back to using the x factor. You've got 36 that'll be placed in the top, 13 in the bottom. So remember that 36 represents the product, where 13 is the sum. So in a good case scenario, you can kind of look at those two numbers and come up with an answer. But if you can't, I'm going to kind of steer you back to one of our tricks from before. So we're going to list all the factors of 36. So 1 times 36, 2 times 18, 3 times 12, 4 times 9, and then 6 times 6. The reason you want to do this is because when we get into the next couple examples, having this list of factors to go back to is going to only help you in the long run. So as we kind of scan through this list, we're trying to see if we have a combination where it's going to add up to a positive 13. So the only one that will work is the 4 and the 9. The rest of them is either too large or too small. The combination then gets placed on either side. So now we can just write out our final answer of x plus 4, x plus 9. And then you're done with this problem. So let's do another one. So again, we're going through, we're going to have our x. We've got negative 28 and negative 3. So again, go through. Let's list all of our factors of 28. 1 times 28, 2 times 14, and then 4 and 7. So now we're looking at one of these numbers is going to have to be negative out of the pairs. So as we're going through, we're trying to find the difference of 3. So as we kind of scan through the list, the only one that I think would work in this case is 4 and 7. The trick now is to figure out which one is going to be negative. So in this case, the 7 should be negative because it has to add up to negative 3, which negative 7 plus 4 is negative 3. So your final answer is just written out, x plus 4, x minus 7. So let's look at something a little bit different. So now we've got this value of a. So anything in front of the x squared, the k squared, the y squared, whatever it might be for a variable, if that's bigger than 1, we have to kind of do one extra step and then rely on some of the other skills that we have. So in this case, what you do is you take your 9 that you have at the beginning and 7, and we're going to multiply those two numbers. So now we get 63. So this is the number that gets placed on the top of our x, and then the middle term gets written on the bottom. So we're still kind of using that whole idea of, what times what will give us, 63, but will add up to negative 24. So as we're going through and just seeing that there's a positive number on the top of our x and a negative number on the bottom, we're most likely going to have two negative numbers. So let's just go through and list all the factors of 63. So you've got 1 times 63, then you've got 3 and 21, and of course we have 9 and 7. So before I go too far, I've kind of already written down my answer, because this 3 and 21, when added together, will give me 24. If I make them both negative, this will satisfy this part. So we know that negative 3 times negative 21 will give us positive 63. And then we add those two negative numbers, we're going to end up getting negative 24. So now we've got this information. So the idea is we're going to use this negative 3 and our negative 21 and then write out some other information. So here you've got 9k squared. We're going to do minus 3k minus 21k plus 7. So now you've got 4 terms. And using these 4 terms, we're now going to factor by grouping, which is something that we haven't seen in a while, but it's a skill that we need to use to figure out the answer. So again, we take a look at the first 2 terms and we say, well, so the idea is then to figure out what the greatest common factor is going to be. So you have 9k squared and 3k, so they both have a 3 that goes into it, and then a k. So we write 3k on the outside of the parentheses, and then it'll be 3k. That's a terrible 3. So you've got 3k minus 1. Then you look at the next 2 terms and you say, all right, what do these have in common? Well, It's going to be a 7, but I'm going to take out a negative 7. And I'll show you why that works in a second. So divide each one by negative 7, and you've got 3k minus 1. So when I looked at the first parenthesis, I saw that it was minus 1. But because of this plus 7, and only in order to make that a negative, we'd have to divide by negative 7. So now we just write out our answer like we've done in the past. So you've got 3k minus 7, and then 3k minus 1. So that's your solution. So again, going back to, you know, taking some of the skills that we've learned before and then putting them all together. So we've got 8n squared minus 51n plus 81. So again, we're going to take the value of 8 and 18 and find the product, which happens to be 144. I'm going to list out all of my factors of 144. So you have 1 and 144. You've got 2 and 72. 3 goes into it, 48. And sometimes these numbers are large, so you're going to have a long list. So let's kind of keep going. So you got 4 goes into it 24 times. Let's see, 5 doesn't go in, but 6 does, 26 times. And then finally, we'll just do 12 and 12. So let's kind of just scan our list. Is there any way that we could possibly get a combination of 51? Because remember, we have a new product of 144, but it has to add up to negative 51. So as I kind of look through my list, 1 and 144 won't work. 2 and 72 won't work. 3 and 48 will work, but I have to make both of them negative. Okay. So let's use this combination, rewrite our original problem, and then factor by grouping. So let's go here. So I'm going to rewrite this so it's 8n squared minus 3n minus 48n plus 18. Okay. Again, factor by grouping. So look at the first two and last two. So you've got this one, we'll just have an n in common. And could you reorganize the numbers, like the 3n and 48n? Absolutely. I'm just going to leave it as is, though, just to show you that it'll give you the same answer. So you have left is 8n minus 3. And then we look at the next two. Well, they don't have an n in common, but they do have a 6 in common. But I'm going to make it negative 6. And then from here, we've got negative 6, and it'll be 8n minus 3. So I'm trying to get it so the parentheses are the same. So if you have to divide by a negative, divide by a negative. Writing out my final answer, n minus 6, 8n minus 3. And we're done.